Hi, we're Group 4, and we are here to present to you acetone-methanol flash distillation.
Our group members consist of Alia, Iman, Mukhi, and Khalid.
As an introduction, the flash distillation is a single-stage separation process used to separate multiple liquid components. So the pressurized liquid is suddenly vaporized by dropping its pressure. And for the applications of the flash distillation, it is usually used on the field of petroleum refining, seawater desalination, natural gas processing, and acid gas treatment. And for the advantages of the flash distillations: simplicity, effective non-volatile solvent recovery, and low relative heat demand. And on the other side, the disadvantage is costly, limited purity, dependent on conditions.
Our project requires us to design a flash distillation unit to separate both acetone and methanol. We then examine the process in standard operating system and calculate the amount of moles that is separated.
We start with the operating conditions. Here are the assumptions. The temperature is 59 Celsius, the pressure is 1 atmospheric pascal, the C is 100 mole, X1 is 0.7, X2 is 0.3, Y1 is 0.7, and Y2 is 0.3. And here is the design of our project. 100 moles of the fee is going through with acetone being 17 moles and methanol being 30 moles. We have to find the amount of separation between both of them, with one going to the vapor phase and the other going to the liquid phase.
For the first step is we must to calculate the saturated pressure for each component, which is acetone and methanol, using Antoine equation. So for the value A, B, C, we must refer the table B2 from appendix book. So this is how we calculated the saturated pressure for each component using Antoine equation by assuming the operating condition at 59 degrees Celsius. As we know that the value of acetone saturated pressure is 111.381 kPa, meanwhile the methanol is 80.26 kPa. This is mean that acetone is more volatile and easily evaporated compared to methanol. So for the second step is we must to identify the bubble pressure. Using a Raoult's law, the formula is a summation of X, the composition of liquid, times with a P saturated for each following each component. So this is our calculation. We already get the value of bubble pressure is 102.045 kilopascal. So by identifying the bubble pressure, we can determine at what level pressure that the bubble form in liquid mixture. So for the next step is we calculate the value of dew pressure, which is the formula is 1 divided by summation of composition vapor, which is Y, divided by P saturated for each component. So this is our calculation, the calculation of dew pressure, which is the value is 99.77 kilopascal. So the purpose to determine the dew pressure is we want to identify at what pressure that the liquid droplet change into the vapor. After comparing all of this pressure, we identify the operating pressure lies between the dew pressure and the bubble pressure. This is mean that the mixture is occur in two-phase region, which is a liquid and vapor phases, occur in one condition. So this is proof that the flash distillation can occur successfully.
Next, we are going to calculate the K value for acetone and methanol. For formula we are using is K equal to P saturated over P. For K acetone, 111.381 is over with 101.325 is equal to 1.099 for K acetone. For K methanol, 80.26 over 101.325 is equal to 0.792 for K methanol. After getting the value of K for acetone and methanol, next we are going to find the value of V and L using iteration method. by using formula summation of Z times K over 1 plus V times K minus 1. Firstly, we have two substance, which is acetone and methanol. So, we need to do summation of these two substance and equal to V, which is here, V is equal to 1. After insert all the input that we have, we get the value for V is equal to 0.33508 mol. To get the value of L, we need to minus the V with 1, which is 1 minus 0.33508, and we get the value for L is 0.66492 mol. Next, we are moving to PXY graph. At 59 degrees Celsius, P saturated acetone is 111.381 kilopascal. P saturated methanol is 80.26 kilopascal. X1 is 10 for mole of liquid for acetone. X2 is 10 for mole of liquid for methanol. P, we can calculate P using P bubble calculation. K1 is P saturated acetone over divided by P. Y1 is K1 times X1. After getting all the value, we can plot X1 and Y1 at x-axis and P at y-axis. After done plotting, we can see that X1 and Y1 increasing by pressure.
Okay, we will continue our calculations, and for this time we will calculate the value of vapor mole fractions, Y1 and Y2. So the formula is shown on the slide, and we already have the value of K and V as we calculated before. So after direct substitutions, the value of Y1 is equal to 0.7446 and the value of Y2 is equal to 0.2554. After that, we will move on to calculate the value of liquid mole fractions, X1 and X2. So the formula as shown is X is equal to Y over K. So for the value of X1, after substitutions, the value will be 0.678 and the value of X2 will be 0.322. Okay, we finish our calculations, and the summary is the moles of vapor V is equal to 33.508 mole, and the moles of liquid L is equal to 66.492 mole. For the liquid mole fractions, for the acetone X1 is equal to 0.678, and for the methanol X2 is equal to 0.322. So on the other side, vapor mole fractions, for the acetone Y1 is equal to 0.7446, and for the methanol Y2 is equal to 0.2554. And at the end, this is our reference, and that's all for our group. Thank you so much.